a woodland path in leafy South Wales, and an old steam locomotive from Texas. What's the connection?
The locomotive, a steam engine that runs on wheels along metal tracks. It's a simple idea now, but at the end of the 18th century it was revolutionary. The story of how the first iron horse hit the tracks begins here in the hills of South Wales. 200 years ago, massive fortunes were being made here by the ironmasters.
They were tough businessmen, pioneers, and their experiments in production and locomotion changed the world forever.
This hill, the Blorange, contained all the raw materials needed to make iron.
Iron ore, limestone, coal. And over there are the ironworks. In 1789, the year of the French Revolution, another revolution started here. A group of enterprising Staffordshire businessmen took a lease on some land at Blaenavon. They built a range of furnaces, the first multi-furnace site to be built from scratch. It was a massive investment, a massive gamble, but it showed massive confidence.
By 1812, 23 years after they were built, these furnaces were the most productive in the world.
The furnaces were set into the hillside, so you could load them up top there with the charge of iron ore, coke and limestone. Then, reaching a temperature of 1500 degrees Celsius, he tapped off the slag, the impurities, and then the molten iron came out of here, onto the casting room floor, which was like a giant mould made of sand. One long channel and a series of side channels, and they reckon it looked like a sow with piglets. Hence the name, pig iron. They were producing 70 tonnes of pig iron per furnace per week. They reckon you could see the smoke for miles. I bet you could smell it as well.
The investment in the works was paying off.
It had the latest technology, a steam engine instead of a water wheel to blow air into the furnaces. These were its feet.
Steam engines had come a long way since the early machines designed to pump water out of mines. There were hundreds of them, pumping and winding in works around the country, but they were still big and unwieldy. Nothing like a locomotive, a compact machine that could move itself around. Steam power couldn't yet solve the ironmasters' great problem: how to get their 50-kilo pigs to market.
Blaenavon has world-class technology and record productivity. And one slight problem: geography. Newport, the gateway to the sea, that means world markets and massive profits, is 24 kilometres that way. Any ideas?
What they needed was a transport network, and this was the age of the canals.
It's a long way down there, and a long way up there. Seems a funny place to build a canal, on the side of a hill.
That was the closest they could get to the ironworks. In this part of Wales, the valleys run north to south, so it's not surprising that waterways were one part of the ironmasters' route to the sea. If they couldn't use the rivers, canals were the next best thing. This is the business end of the canal, the toll house. See, ironworks. In this narrow section here, which could be closed off at either ends, the boats would be gauged, measured, and the tolls calculated. Charity not being one of the priorities for canal promoters. Pig iron, finished iron, 3d per tonne per mile. Iron ore, 2d per tonne per mile. Limestone, penny per tonne per mile. But there could be understanding though. Throughout the history of the canals, coal was always measured at 2100 weights per tonne. That's an extra 100 weight to allow for personal allowance and the constant pilfering from canal boats. This is a small version of the boats that use this canal, and they were bulk carriers.
It's incredibly simply constructed, very similar to the Worsley mine boats and other boats of that type, the Birmingham boats, all day boats. Didn't have proper accommodation because it was only working a short stretch of canal, and it did a very simple job. It carried materials in bulk.
The canals could go up the valleys and along the hillsides, but they couldn't go all the way up the hill to the ironworks. There was a missing link. An Act of Parliament authorising the canal near Blaenavon also gave permission for railways to ironworks and mines in the area. But they hadn't invented locomotives, so what were these railways for? To find the answer, we have to go deep into the Blorenge Hill to look at the coal mines.
In an 1812 time and motion study in a Scottish mine, it was found that women were dragging 70-kilo baskets of coal 50 metres to the shaft, and then up a vertical ladder for 40 metres 24 times a day. That meant that each one of them was carrying 2 tons over 2,000 metres through tunnels and up shafts, and for that they got 8p. As the demand for coal grew and deep mining developed, the old manual labour systems weren't good enough. This is a bulk system. This is a dram or tram, and it runs on a tramway. Cast iron rails, trams with cast iron wheels, taking loads of coal along the mine workings to be taken to the surface. And what better way to pull them than with a pony? Tiger, Essex, what mate, Albert, Bounce, Victor, who was the last resident and left in 1972. Eventually the motive power went from ponies to machines. Steam, later, much later, electric. But the tramway system stayed the same. A narrow gauge, friction friendly bulk transport system that was incredibly adaptable. God bless the man with peace and plenty who first invented metal plate. Draw out his life to 5 times 20 and slide him through the heavenly gate.
These metal plate tramways seem to be just what the ironmasters were looking for.
Llanvoist Wharf on the Brecon and Abergavenny Canal. A peaceful, not to say rural place, but 200 years ago this would have been busier than Spaghetti Junction and twice as dangerous. So what's happening here? This doesn't look like a normal canal bridge. It's not humpbacked, it's flat. And why build a pedestrian tunnel under the canal when you've got a perfectly good flat bridge over the top of it? And it's this relic that finally gives the game away. It's the rusting skeleton of an old wagon that was designed to run on metal rails.
These trams use the same technology as in the mines. They are the missing link between the canal and the ironworks on the other side of the hill.
This was a tramway, and this was a tramway, and this tramway went over the flat top bridge, and it started up there. And this is the route of the tramway. It's over 300 metres up there to the top of the Blorenge Hill, and over 2 kilometres to the ironworks. This was the ironmasters' route to the sea. They were desperate to get their iron out, and this took advantage of a cheap deal with the canal down at the bottom there. It was built with cast iron rails, with the trams dragged up using gravity and manila ropes. It was built right at the limits of technology. Imagine one of those trams full of 50-kilo pigs hurtling down that hill. No wonder they built a pedestrian tunnel. It just shows how important this area was.
This was a 2-lane highway, a 3-stage self-acting incline. The full trams going down pulled up the empties from the wharf.
This is the summit level of the tramway. Inclines are back there. The ironworks are that way, and this is where horse locomotion took over. They used gravity back there. If you look down here, you can see the stone sleepers. These holes here took the wooden pins that anchored the cast iron rails in sections. And because this was horse powered along this section, you couldn't have traverse members because the horse had to walk in between. This is a tramway here. There's one over there. There's one going up there. There's one up there on another level. There was an extraordinary network of tramways, both across and through the hill. This used to be one. It brought limestone from the quarries of Tilla and Prushdi and then into the tunnel here. And emerged here, 1.8 kilometres later, the other side of Blorange Hill, just metres away from the ironworks. They like the tunnels around here. This whole tramway system was a fantastic feat of engineering that linked the ironworks through that hill there to the canal, the other side of that hill there. But what has this got to do with the birth of the railways?
And then all hell broke loose.
These are enormously powerful phenomena with the strength of hundreds of nuclear bombs.
Tornadoes are like an animal. Before you can hunt them down, you have to know how it behaves. We'll get in the van and it's going to kill us.
Oh my God!
From my perspective, things are just continuing to get worse and worse and worse.
Will you survive? Extreme weather tonight from 8 on Discovery Channel.
Two litres of water a day, 30 minutes exercise a day, 8 hours sleep a night, and 1 little bottle of love.
Do that again.
Muller Vitality, full of feel-good bacteria.
This year, Sirius Black has escaped from Azkaban prison. Everything you expected
If you want to kill Harry, you'll have to kill us too.
will be transformed.
Only one will die tonight.
Expecto Patronum! Harry Potter and the Prisoner of Azkaban.
Now the DVLA don't need to look here for out-of-date tax discs. They don't even need to look here or here. If your car tax is out of date or if you haven't declared your car as off the road, there's only one place the DVLA now need to look. Here. And if you aren't up to date, the database will automatically issue an £80 penalty. Here. The new car tax rules. Are you up to date?
Oi, Churchill! I see you couldn't save any of those penalties, direct or indirect free kick.
Obviously not.
Nor could you save us from alien invasion.
No.
But you could save us money on our car insurance.
Oh, yes.
Yes, Churchill could save you up to 30% on car insurance. Call him now on 0800 917 7624 or visit him at churchill.com.
Go home.
No.
So far at Safeway, we've lowered 7,902 prices, and we'll continue to lower more and more prices throughout the store. Safeway, now part of the Morrisons family. Enjoy the change.
Keep missing Discovery Channel? Don't worry, with broadband you can view programs on demand whenever you get a free moment. And why not interact with your girlfriend, television, and win fantastic holidays and other groovy stuff? Download ringtones from the Discovery website that are so realistic you can have all kinds of fun. And when online, check out the latest program information and even take the first flight in history with the Wright brothers. In fact, there's a whole world of Discovery Channel, broadband, mobile, online, interactive. You've just got to know.
The hills and valleys of South Wales now had a network of metal railways, but for horse-drawn trams. What was needed was a breakthrough in steam technology. From the 1770s, the steam engine market was dominated by the partnership of Bolton and Watt. They had made some improvements in efficiency, but their engines, using massive copper boilers like giant kettles, had serious limitations. To get more power, they had to build bigger and bigger machines. And working at low pressure, £5 per square inch, there was no way these machines were ever going to move themselves along a track. Bolton and Watt used patents to keep a stranglehold on their competitors, preventing new ideas from breaking through. Finally, in 1800, the patents expired and the cork was out of the bottle. Down in Cornwall, the man with the next big idea, high-pressure steam, was waiting in the wings. Richard Trevithick, a mining engineer with a passion for steam, was dreaming of small, powerful engines, powerful enough to do a range of jobs, and small enough to move themselves around. High-pressure locomotion. This was the way of the future, the technology of the steam railways. Steam, kept at high pressure in cast iron boilers, meant that engines could stay small but still pack a hefty punch. But going from engines working at £5 to £150 per square inch was a massive leap, as one of Trevithick's colleagues found out. We stood near the boiler, if not exactly on it, and when I came to calculate the pressure exerted on the flat surface of the iron, I came to the conclusion that my life had never been in such imminent danger. Trevithick wasn't alone in experimenting with high-pressure steam, but any newcomers met heavy opposition. Not surprisingly, Bolton and Watt didn't want to become dinosaurs of the steam age, and when a high-pressure boiler exploded at Greenwich, they spread scare stories about high-pressure steam. Despite the risks, Trevithick saw endless possibilities for his high-pressure engines. He developed a range of powerful stationary machines for the mining industry, but his dream was to get them moving under their own steam. He tried a road locomotive at first, but it was difficult to steer. What he needed was rails. Trevithick's earliest tests on a rail locomotive in Shropshire were held in secret, probably because of Bolton and Watt's scaremongering. Like any pioneer, Trevithick was attacked by the old guard, as he later recalled. I have been branded with folly and madness for attempting what the world calls impossibilities. Even the great engineer, Mr. James Watt, said that I deserved hanging for bringing into use the high-pressure engine. In a sense, Trevithick's detractors were correct. High-pressure steam can be dangerous if it's left unattended. This high-pressure steam locomotive has constant attendance and has a series of safety valves that make this a safe way of working with high-pressure steam. But the gamble had to be taken, and Trevithick at that time was the only man who would do it. What he needed was a patron, and who better than an iron master already familiar with steam technology, employing skilled workers able to manufacture an iron locomotive. In 1804, Samuel Homfray, one of the great ironmasters of South Wales, summoned Trevithick to his works at Penydarren to show him what high-pressure steam engines could do. This was Trevithick's big chance. A tramway had been built, like the one at Blaenavon, to link Humphrey's works with the canal at Abercynon, but this time there were no dramatic hills, just a steady incline of 1 in 145. Perfect for the trials of the world's first steam locomotive. Humphrey's great rival in the area was Richard Crawshay, and this is the family seat at Merthyr Tydfil. There was money in them dar hills. Crawshay heard of Trevithick's visit and saw an opportunity to make a mockery of the competition. Smooth wheels on smooth rails. He wagered 500 guineas, 14 years' salary for an ordinary ironworker, that the locomotive would not be able to pull 10 tons along the 9.5-mile stretch of tramway between Merthyr Tydfil and Abercynon. Could the iron horse do the same work as a pony and trams? Samuel Humphrey took on the bet with confidence, probably because he'd heard positive reports about Trevithick's secret trial run in Shropshire the previous year. And this is a replica of that secret locomotive. All right, Alan?
Hi, Mark. How you doing, mate?
Thank you, driver. Carry on. This is the first locomotive in the world. Built by Trevithick over the winter of 1802. It's a living dinosaur in the nicest possible sense. And we're talking 10 years before George Stephenson's first attempts hit the tracks. Trevithick's tram wagon, as he called it, had a cast iron boiler that could sustain 150 pounds per square inch of pressure, the same pressure that steam locomotives still run on today. It had an 8¼ inch diameter cylinder with a 54-inch stroke that was set into the boiler immediately above the flue. The piston rod connected to a crosshead reaching right across the engine, and from here the drive was taken through gears to the 2 wheels on the left hand side and to a larger flywheel. The locomotive was cleverly designed to work as a static machine as well as on the move. It's not the easiest thing to drive, and, slight problem, there's no brakes. To stop it, you have to turn off the regulator to cut off the steam, keep an eye on the valve, grab the lever at just the right moment, and put it into reverse. To us, it looks old and quaint, but to some of Trevithick's contemporaries, it seemed like a monster on wheels. A man by the name of Trevithick has lately invented a machine that goes without horses. It travels with great velocity. The danger seems to be of the water being exhausted and the vehicle catching fire. It is, I'm told, a very large and ugly machine and will be very frightful to a horse. But down at the Penydarren tramway, the iron horse was performing well at first. Samuel Humphrey wrote, "I have the satisfaction to inform you that our tram road engine goes very well. We made a journey on our tram road of 9.5 miles. It took 10 tons of iron and 60 or 70 people riding on the trams. It goes very easy at 4 miles per hour and is much more manageable than horses." It seemed that Trevithick's locomotive had done everything required to win the bet. But the result was unsportingly challenged on a technicality, because some of the original tracks were moved. So much for the 500 guineas. There's no record of any money changing hands. What was worse for Trevithick, the trials exposed a major technical hitch, not with the engine, but with the tracks. The heavy locomotive had a disturbing tendency to smash the brittle cast iron rails. And that's what discouraged Trevithick from developing the locomotive, and gave George Stephenson the chance to claim all the glory as the father of the railways. The truth is that the original steam locomotive was born out of a mix of Cornish genius and hard-nosed industrial competition. Thanks to the pioneering engineering of Trevithick and the canals and tramways of South Wales, the Iron Horse soon became a reality, and shortly it took over the world. Come on, Clive, I'll race you. And the story has now come full circle. A few miles away from those leafy tracks in South Wales, a locomotive from Texas now runs along the Brecon Mountain Railway. Same principle, different scale. Next time, I'll be looking at how steam came off the rails and onto the water. The human frame will be unable to bear such velocity. Lungs will burst, eyes will pop out from skulls, and the skin will verily be flayed from people's bodies. It is unnatural, sir, unnatural.
If you had a clue as to what you were talking about, you'd be dangerous. Come over here and turn around so